Okay, big three here discussing structures. What is a structure? A structure can be any, here is a structure. This structure is very similar to the one in the book. And the ones in the book have simple pinned joints. So any force applied to the structure, say it's a bridge and it's a truck going over to something, it's going to all be centered, all the force will be centered on the pin joints. Okay, two main things with structures. Structures are loaded and structures are supported. Now, structures can be loaded by different things. Gravity, structures, that would include its own weight, signs on the roadbed, depending on what the structure is. And structures are also supported. Those are things like these. The supports, the beams, the joints. And when a structure is undergone a force, when a structure...
A truck is driving over this bridge. And this bridge is going to be exerting a resistance force equal to the truck's weight, mass, etc. The forces will be equal, but if the truck weighs too much, the bridge will collapse, and it'll be bad, just like that.
Okay, as you can see here, our bridge just broke under way too much stress. So let's put it back together so you can keep using it. And that's exactly what we're supposed to do.
I'm going to be the class.
Two main types of supports that are given are fixed supports and roller supports. Both just support the structure so it won't collapse or whatever.
Here's a fixed support, and here's a roller support.
And here we have them bigger. Now, a fixed support, reaction forces can be in the x direction and the y direction. The reaction forces being, again, the forces that the bridge is going to exert on the load. The load is exerting on the bridge is exerting on the load. The reaction forces keep the load in the air, for this example. Okay.
In a bridge. Keeps it up.
Now the roller support, since it's on rollers, it can roll. The reaction forces are absorbed, sort of, in the x direction. So, because it's on rollers, the main reaction forces are only in the y direction. Okay, now here we have another structure. You're going to have to use your imagination a little bit because this is actually a 60-60-60 equilateral triangle, even though it doesn't look like it. And here we have a mass of 1 kilogram hanging on it. Now, since this structure is supposed to be in static equilibrium, that means it's not moving at all, it's staying right there. The bridge, or the truss, has to exert a reaction force equal to the force the mass is pulling on it. So, we can split it up into a sort of a vector problem. This one's going to be right this time.
And we're great at vectors.
Alright.
Yeah.
So, if our mass is 1 kilogram, our force is going to be just mass times acceleration, so it should be around 9.81 newtons. So force is equal to 9.81. Alright, now to find our x component of the force in these trusses, it would be F times the cosine of 60 degrees.
And we're doing this in degrees, correct?
Yes.
Alright.
Alright.
So x is 4.950
newtons.
Newtons.
Yes.
That's important.
Now, the reaction force for y is going to be force times the sine of 60 degrees.
Also in degrees.
And that's going to be equal to 8.4957 newtons. So the reaction force in the y dimension is still greater than in the x dimension. Even though that might not be very easy to visualize here, that is true because we stated it's a 60-60-60 triangle. Okay, so that's pretty much all we have to say about trusses right now. That's us all from Big 3. 1, 2, 3.
Yeah, we can count.